Are you ready?
I'm ready.
All right, here we go, Jay.
Hello, and welcome to this week's College of Engineering Virtual Brown Bag Seminar. Today we have with us Dr. Erick Jones, and he's going to be talking about reproducible research. Just as a special reminder, as always, you can watch any of the previous virtual brown bag seminars. There is the link in the chat. It's generally go.uta.edu/COE-VBB, standing for virtual brown bag. So let me go ahead and just further introduce Dr. Jones. Erick Jones is an assistant professor in the IMSE department at UT Arlington and the founder and director of the Sustainable and Equitable Allocation of Resources, or SEER Lab. He obtained a Ph.D. from the Operations, Research, and Industrial Engineering program at the University of Texas at Austin, a bachelor's in science in chemical engineering from Texas A&M University, and is a fellow of GEM, NSF, INFEWS, and DOE MLEF. He spent several years working in the design, manufacturing, oil and gas, and HVAC industries. During this time, he traveled around the world and witnessed how the lack of basic infrastructure like electricity, HVAC systems, clean water, internet, and banking negatively affects the quality of life of the majority of the world's population. These experiences motivated him to pursue research that can enhance quality of life by improving access to sustainable resources and economic opportunities, particularly where a lack of physical infrastructure or economic resources presents a major obstacle, leading to the creation of the SEER Lab. The SEER Lab investigates how communities, companies, and countries can allocate their limited resources in a way that maximizes their desired outcomes in a sustainable, equitable, and resilient, but also elegant way. The SEER Lab assesses these problems by combining physical experimentation, data analytics, and stochastic systems optimization to provide actionable decisions and create scalable prototypes. And so thank you very much, Dr. Jones, for being here. I think at this point, I'll go ahead and turn off my camera and we'll switch on over to him. Thank you.
All right, thanks for that introduction, Dr. Rosenberger. My name is Erick Jones, and today we're talking about research, publications, and modern academic tools. So quick outline, introduction. We're going to introduce what this is about. What is research? What is engineering research? Why is research? Talk about the engineering process, academic papers, annotated bibliographies, literature review, and then reproducibility aids. Introduction. So we've all heard of research or even do research, but can we define it? Is there a difference between basic research and engineering research? How are academic papers, which are the main output of research, structured? What's the difference between a literature review and an annotated bibliography? And what modern software helps with data reproducibility, as well as citations and paper writing? So that is what we're going to discuss today. Research. So UTA's Internal Review Board training has a long modules of a bunch of slides where you're going over all the things you have to do to conduct just research, things that are ethical. And they have this one slide in there at the very beginning that says that federal regulations define research as a systematic investigation that's designed to develop or contribute to generalizable knowledge. So a lot of us will have to go through IRB training, and that really spoke to me because it describes what research is very succinctly, that the key aspect of it is it's systematic and that you can contribute to generalizable knowledge. But going for more sources, Hampshire College here says that research is, again, a systematic inquiry and is conducted to either evaluate the validity of a hypothesis, to assemble a body of substantial knowledge, or to generate questions for future inquiries. Going on, I went to the SOAS, University of London School, and they define research again as a systematic inquiry that seeks to answer a problem, very succinct. From the National Library of Medicine, specifically the Arab Journal of Urology, they define research as a systematic and scientific approach. It's the search for scientific knowledge, and is once again a systematically formal process to increase the fund of knowledge. The University of Georgia also defines it as a process of investigation. It's not just a trip to the library. You pick up a stack of materials and you just notice the first 5 hits from research is a hunt for truth. And research is a way to educate yourself. So that is what research is in general, but what about engineering research? The NSF, or the National Science Foundation, breaks it down like this. They say that funded engineering researchers create new knowledge, concepts, and designs that become technological breakthroughs and solve real-world problems. And there's a bunch of different applications we do that in. Continuing along that thread, the National Academies of Science and Engineering say that basic science is concerned with the discovery of new phenomena and their integration into coherent conceptual models, either physical or biological. So you think the physicists are building giant telescopes to look at black holes to see, why is information lost across the event horizon, even though that should be impossible. Or biological systems they're looking to sequence genomes just to sequence genomes. So basic research in engineering is slightly different. It's concerned with the discovery and systematic conceptual structure and knowledge. That should sound familiar. But virtually all engineering research is driven by the value of an application. So you're not just looking at things just to look at them, as well our pure basic researchers in the science fields do, but you want to have an application that has value in the real world. So we're not just looking at knowledge of natural phenomenon, but also how this knowledge can serve humankind's wants and needs. And as a result, we integrate knowledge across a variety of fields. So that is research, basic research, and engineering research. So why research? So again, from the National Library of Medicine, from the Erick Journal of Urology, research is the future fuel. So it helps progress perspectives in medicine. For example, in urology, the practice has rapidly changed with a few key research findings. Again, from the University of London School, research is concerned with increasing our understanding. It provides us information and knowledge that helps us solve problems, both in pure and applied. And then there's these 5 areas of research that we can describe how things are, we can explain how these things are, they're analytical, we can predict things. That's where machine learning excels, prescription and planning, so we can help make decisions, or we can monitor and evaluate things such as the CO2 in the atmosphere or the lead in our water. So common things here, the takeaways are that research is a systematic investigation. Every definition has the word system, systematic, and investigation design. You have to structure it some way, so conceptual structuring and modeling. And the main goal of it is to increase generalizable knowledge. So not just to research things that you think are interesting or only interesting to you or maybe one other person, but they're generalizable so that other people can take what you've researched and apply it to other things. And of course, you address a research question. Engineering research is slightly different than basic because it solves a real world problem and has a value component that applies this knowledge to address human needs and wants. So now that we've defined research, engineering research, and what it is, let's talk about the research process. From the UTA library, process is pretty simple. You develop a topic, you find some information, you evaluate the information, and then you start writing. There's a bunch of different things you can do. You can take notes, you can utilize writing and grammar resources, and the 2 things we're focusing on today are annotated bibliography and literature review, and of course, citing your sources. And then they also have a step where you check your legal and ethical use. From the University of Nebraska-Lincoln, they define it slightly differently. You identify your research problem, very important. You review the literature, you determine your question from there, then you develop your methods, collect and analyze data, document the work, so that's your writing, communicate it, then you refine, expand, pioneer. So those are the next steps. So the academic paper structure, hopefully this is familiar, but just in case it's not, it follows the IMRAD format: introductions, methods, results, and discussion. And the actual elements of an academic paper include the abstract, the intro, the literature review, methods, results, discussion, acknowledgments, and references. So the abstract is a summary and it tells you what the study's main hypotheses were and the main findings. The introduction gives you all the background information. But the literature review tells you the current state of knowledge on the topic, and it identifies the problems or gaps in their research, and that is where you generally want your research to focus. You review the state of knowledge, and then you say, there is a gap here in X, and this is what we're seeking to address with our research question, which we've highlighted in the introduction abstract. Then you talk about what methods you use, you summarize your results, and then you discuss them. So you don't just, I found X here, here's my graph, this graph shows this. You explain those things in discussion, the shortcomings of your study, the main conclusions, where this will lead in the future, etc. So that is the academic paper structure, and we're going to be focusing on literature review today. So annotated bibliography, what is that? It's Definitions, a list of citations. Books, articles, where each citation is followed by a brief, about 150 word description and paragraph. But unlike abstracts, which are just descriptive summaries, annotations are descriptive and critical. So the main purpose of these is to inform the reader of the relevance and accuracy of the quality of their sources, and then to have the point of view critiqued. Were they clear? Was the research interesting? What can be taken from that, etc. And with here at UTA, in our LibGuides, we have pretty good examples. I'm going to go ahead and click on one of those. Doesn't crash everything. So, all right, here's an example of annotated bibliography from UTA's own library. Here's the citation in APA format, I'm guessing. And it says the authors, they looked at the data, so you summarize what they did. They found their hypothesis strongly supported females, increasing the time away from individualism. And then you have your critique. In contrast, the study by William Sided showed that there's no significance. So they found some result, and you say they found a different one. And here's another example here. So this is what the annotated bibliography looks like. Citation followed by around 150 words explaining it and having a small critique of it. I think these are the same purpose. So that is an annotated bibliography. There's also, before you get to the annotated bibliography, you have to read the work. There's this excellent template had by this website, which is in the slides, that explains how you can read in a research paper. So what do you do here? You find out what are the motivations from the work, what is the proposed solution, what is the work's evaluation of the proposed solution. So they have a hypothesis, they test it. How well did that work out? How did they evaluate that? And then what is your analysis of the identified problem, idea, evaluation? Is it good? Did the work go where you thought it was going to? Are there errors in it? What are the contributions? So how does this push forward the field? What is the generalizable knowledge? And what are the future directions for this research? What questions are you left with? And what's the takeaway message? And then there is a nice little standard template. So if you find yourself doing this type of work, there's this 2-pager that asks all these questions that you fill out. I found it very helpful for doing journal reviews, so I like to tell people it's here. Okay, so back to the slides. Literature review. So an annotated bibliography is you review one paper and then you have the citation, you have a quick summary along with your critique. But a literature review is a whole summary of a published field, and this is a section of a paper or article, or some articles, just the entire paper where they just survey the entire field. And it shows that you have examined the breadth of knowledge related to your research question, and they're actually excellent tools for knowing what's in the field of knowledge and then how you can push that forward with your own research. And unlike annotated bibliography, which are short descriptions, literature reviews are synthesize these sources into a summary that has its own thesis, statement of purpose, etc. So step 1, you define your research scope. So what research are you looking at? You identify the literature, you critically analyze the literature, and then you categorize your resources. So the University of Berkeley has a pretty good example. This is a small example. So health disparities among the homeless population. So let me zoom in a little bit. Substance abuse, serious mental illness exacerbates morbidity, and then have these citations. So they're not just one, but multiple citations. Describe what is known, identify gaps. So there's little research conducted on the unique healthcare perspective of homeless people in rural areas, despite the fact, etc. And so they set the context, they describe what is known, and then they identify the gaps. This is a very short but concise example of what a literature review is compared to an annotated bibliography, which is one paper and then a description and critique of that. So going back to the slides. So those are main ideas behind annotated bibliography and literature review. Now we're going to get to reproducibility. What are the actual tools to help you with all these things? So reproducibility includes a lot of things, includes data management, data best practices, software best practices, which I'll show you in some GitHub templates, project management. There's a ton of resources out there. So there's documentation tools, so notebook tools, RStudio, Jupyter Notebooks. I'm going to show Google Colab. Then how do you write these things? So LaTeX is a software that can help you with that, and Overleaf is an IDE for that. And then there's citation software as well. And all these things have a bit of a learning curve, but they can help you produce research that is much quicker than if you wrote this all in Word, trying to find documents, references, etc. So I'm gonna walk you through all that. So standards and code notebooks. So there's a standard reproducibility GitHub standard I'll talk about. RStudio Cloud is the online version of RStudio. It's easier to get started with, so I'll show you how that works. It's limited in RAM though, so for big projects, you probably want that desktop version. Google Colab is Google's version of Jupyter Notebooks, and again, it runs into the same problem as RStudio, where you have limited RAM because it's on the cloud. They don't give you infinite access, but it's great for sharing documents with other researchers that you're working with, collaborators, etc., and just to getting you started without having to download Anaconda, figure out all packages you need, etc. So the first thing we're gonna do is show you the GitHub project folder template. So let me get out of here. That is this. So data reproducibility is very helpful if you have a structure for how you put in your data. So I'm assuming that we've heard of GitHub. It's a place where you can upload and download your code, and it tracks who's uploaded code last, what edits that they made, etc. It's very helpful for collaboration. But how do you put things in here in a way that people can understand? So 6 months from now, when the project's over, you're like, oh, I only looked at that code and it's jumbled up, it's everywhere, you can't really find anything. This is a very easy structure to use. This is a free, it's called the Good Enough project template. It's free and it covers the basics of reproducibility here. So they have a little legend. PG stands for project generated, HW is for human writable, RO is for read only. Each folder has a citation, license file, the README, the requirements text, and then the first folder, bin, you compile external code. This is ignored by Git. This is project generated. And then any external source code, which is again ignored by Git, and that is read only. You have your configuration files, which is human writable, and you have your data. So you have the final data sets that you use for modeling. You have the raw data that you got from whatever source you have here. You have your temporary data that's being transformed. Then you have your document. So these are your markdown documents, which we'll talk about. That's how you type your papers, your manuscripts, etc. And then you have your report documents. So that's Jupyter Notebooks and our markdown files, which we'll talk about in a bit. And then you have your outputs. So your figures, for the manuscripts, and then your other outputs, so CSV files, etc. And then of course your source code has its own folder, so you don't lose that. So that's the folder structure. What does it look like? So here, citation, click on that. That tells you how to cite the project if you want people to be able to cite it and give you credit for your work. License file, they use an MIT license. Basically says that you can use it. There's no warranty. You can use it for pretty much anything. You just have to cite where they got it from. README. So this is what you put everything that they need to know in here. So they put the folder structure here because there's no code in here, but you would add, what temporary files would you need, what manuscript files, etc. So we would describe the things that are in the folders. And then the requirements text, and here's blank, but this will be anything that they need to run your code. So I'm using Python version 3, etc. That would go there. Your config file, anything that you need for your configuration. This is all your external code, your docs folder, manuscript report, etc. And then here's your source code, here's your actual code goes. So I have an example, but I'll show that in RStudio. So that is a good template for using a reproducible template so everyone can know what your code is, how to find it, etc. And again, this is the Good Enough project template available on GitHub. The link is also in the presentation. Okay. I seem to have lost. There it is. Okay. The next is Google Colab. So Google Colab is Google's version of Jupyter Notebooks. So if you go to Colab, just Google Colab. So Google Colab pops up. The very first thing is welcome to Collaboratory. So I have that file over here. So this file pops up. The first thing you Google, it has a nice little video explaining what it is, and it allows you to write or execute Python in your browser with zero configuration, access to GPUs free of charge, and easy sharing. It just breaks down all the easy the hurdles for Python immediately, and you can share this in the Google Drive. It's easy to share, so up here in the upper right-hand corner, share it with your friends. Just give them the link, and they can see exactly what you've done, and it works off the shelf. So here's some code. It runs, works out pretty well. You can import. It also has a bunch of packages that you don't have to install yourself. They're already on the Google Cloud. Play here, produces some visualization, etc. It's very helpful, and I've used it to teach the basics of optimization to some of my research group. So there, Gurobi is where this file came from, and the cool thing about Python and Jupyter Notebooks is that this chunk of code is written in Markdown, which is a text format that can be used. So Markdown. It's a free and open source. I'll explain. I don't know. So what is Markdown? What is Markdown? It's a lightweight markup language that you can use to add formatting in plain text documents. That's what Markdown is. And you can write in Markdown in these Jupyter Notebooks. So this is all just regular text that they've written down. If you double click it, there's a code for it. So this is the heading code, subheading code. You can put links in, etc. This is all things you can do in a Jupyter Notebook, and Google Colab is Google's version of that. So let me stop that. Escape. You can also run regular Python code. So this is that should work right here. And import these packages. You can put these nice little tables and images in here. So I'll double click here. Here's their image. That's where that came from. It's a raw PNG file located in their GitHub, it seems. And you can, write exactly what you're looking at. And escape. And you can run all these things. So these are sets. These are ran into a problem. Have to install it first. So every now and again, you do have to install something on Google Lab, but relatively straightforward. Pip install right from the notebook, easy enough. You can run these packages, run each line of each chunk of code, makes it much easier to read, etc. Do all this, play here. Eventually, Roby run a solver. Here we go. So you run the LP. And I just ran a linear program in Google Colab without installing anything. I just copied the link from Gurobi, installed the proper package, and here are the results of my objective function, etc. So that is Google Colab. Recommend it. It's easy to start an account. You just need your Gmail, and then you just go to googlecolab.com. It opens it up, and it creates a collab folder for you. So what does mine look like? So when you start a Google Colab folder, it creates a new one for you. So let me just file, locate and drive. So here's my drive. It creates this nice little folder that has a different color than all of them. So Google, and then here is that file I was working on. Here's some other files I've had in the past. And you can share these. You can actually share this folder with anyone you're working with. So it's very, very, very handy. Okay. The next is RStudio. So Jupyter Notebooks and Google Colab runs on Python. You can technically run R code in it, but if you really want to run R code, you go to RStudio, and rstudio.cloud is R's version of this cloud-based platform where, once again, you don't need to install anything. It all comes prepackaged. You might have to, install a few packages like the tidyverse, but you don't have to install the actual IDE or R itself. It runs on the cloud, and again, you can share. So if I want to share a project link, I'll just go to the top right-hand corner, and I can send bob@uta.edu. Here is my RStudio code, etc. So it's easy to share, easy to work, and if you have don't know how any of this works, it's all here. So I'm going to start closing it. So I use this for my probability class. So this is what these files are. So I'm going to start from just this. I want to share this. And close that too. So I have over here, I don't know how it's RStudio, let me zoom out real quick, has there's 4 panels. Right now there's only 3. So there's the console where you can just run regular R. So 1 + 1 is 2. But I created a project called Example, which follows a similar format to the Good Enough project, but I simplified it a little bit. So I have my data folder here. So I'm over here in the bottom right corner at my docs, which is empty, my functions, the notebook files, and results where I output CSVs, figures, and others. So I'm going to open this notebook, and this is the 4 panels of RStudio. So let me make these all a little bigger so you can see. The top left is, again, a markdown type document. So you can write markdown just like you could in Jupyter Notebook. So this same process up here, where this is markdown, this is markdown. So you can write whatever you want to in here, just regular text. So text goes here. Then in here are your chunks. So in here is R, because technically you can run Python, you can run Julia in these chunks, but obviously R is native, so it runs faster. And here I put your libraries, my user imported functions, I import my data, and then I have these data sets. I visualize this data set. So that session, start R, run all chunks. So generally when I'm coding in here, I don't need the console, so I'll minimize it. There it is. That's an outline, which I also don't need right now. And I've installed the package that I need, tidy version skimr. I've sourced these function I created. I've downloaded this from a CSV file that I have. If you remember from the Good Enough project, you put all your data in a raw folder or a temporary folder, depending on what type of data it is. So I'm taking this from the data folder, just in general, calendar CSV. I'm visualizing this data in R. I tidy it up. I take a look at what's here, etc., and then I plot it. So all this is, I can take this folder, put this on GitHub, and everyone should be able to follow it because, again, I have a README explaining where all this stuff goes. So this is now applying the GitHub thing to RStudio, which is another tool that you can use online without having to install anything. It works out the box, and you can share it with everyone just like you can Google Colab. So that's some of the power of R and Python. That's what else we have. So that's RStudio. The next, so that's coding, visualization, data analytics. You can use Colab, you can use RStudio, and you can have that in a nice format in GitHub so that you can share that in the future with yourself or with other people. So in 6 months from now, you can actually find everything where it goes. It all flows freely. You have a README file, helps you reproduce the research, or if someone reads a paper you have and they're like, oh, how do you run this code? You can share them the GitHub file and they can actually follow it. There's a lot of research out there where they just single source code, they run some ML model and they produce some results, they write a paper, and somebody talks to them like 6 months, a year later, like, oh, how'd you run this code? And like, oh, it's on GitHub. They give it to GitHub, so I can't run this, can you help me out? And they can't even figure out how they ran the code because it's not in a structure that's easily followable. So hopefully I gave you a little taste of how to make reproducible research in one RStudio, Google Colab / Jupyter Notebooks, and how to put all that in a folder in GitHub. Now we're going to writing. So reference managers are citation management tools that help you manage your research, collect and cite your sources, and create bibliographies and a variety of citation styles. There's a lot of strengths and weaknesses, but they're much easier than doing this by hand or typing it in Word. So there's two main reference managers. There's more, but these are the ones everyone knows. Zotero, it's free and open source by academics for academics. And then there's Mendeley by Elsevier, which is a pretty popular journal aggregator. And we're going to go over Mendeley just because that happens to be the one I use. So demonstration on Mendeley. So I have the desktop version, but again, like most things in life now, there is a online version. So here is all the references I've ever added to anything all in one place. But like most things, I have them in folders. So this one's for some grant I wrote for size. Here's one on construction and management. Here's my food stuff, farm model paper, which is the second paper, my third paper of my dissertation. System modeling paper, so anything I just find interesting, etc. And it's pretty easy to add things here. So if I just go to Google Scholar, and this seems like a good paper. Understanding shared autonomous vehicle preferences comparison between shells, right axes. So I've already installed this extension called the Mendeley Web Importer, but you can also just click here. So the thing pops up once you install that. You can click here. Takes a little bit. Not the fastest. It shouldn't be this slow though. Well, give it a second. Well, the faster way is just to hit this button. It loads up. It'll take its time a little bit. And then you can pick what folder you want to add it to. So I have a bunch of collections, construction management, crime, sustainability, energy and transportation. It seems like a good spot for it. Transportation. I click here, add it, and then Let's check. It's right. My folder. This is beyond just your own citations. One more thing. So the reason that you go through all this trouble is because you can click it on the bottom here, export as a bib file, but no, there's a better way. You can right click this, copy formatted citation. So if I just open up a random text file, so let me go to docs. So all I did here was I right clicked on this, copied as a formatted citation, the new reference I just had. I'll open up the Google Doc, hey, Control V, perfect formatted citation. This is the hard way to do it, but it's actually pretty convenient. If you're writing a paper with maybe 7 references, you can add them to Mendeley and it automatically formats it as a citation in the correct format. So that's helpful. But beyond that, I had my team add a bunch of papers to this energy poverty folder. So there's groups you can make. And in this group, let's see here, to the manage group, you can add a bunch of members. So here's some part of my team. I added 12 of them, and I told them just to add random files to here. And they've all added these from, most of these aren't from me. They're either from my team or somewhere else. And I've created different folders for them to add things to. And if I want all this as a bibliography file, hit Control here, export as a bib file. And if I open this bib file, all the reference citations for anything that my team has put in this folder is here, and we can import this into LaTeX. And that is the next thing we'll go over. Oh, back to the slides. So adding articles to the shared Mendeley folder is relatively easy. You just get the Mendeley extension for Chrome. You look up an academic article like I did. You add it to the folder using the extension. You make sure that the details are right. You highlight all the references in that shared folder, which I did, and you export it as a bib file. So I just showed you all those steps. The next thing we want to look at is LaTeX, pronounced LaTeX, which is a document preparation system for high quality typesetting. It's most often used in these medium to large technical or scientific documents, but almost any form of publishing. It's not a word processor, it's a typesetting document preparation system, but it encourages you not to look at the appearance of the documents, but concentrate on getting the right content. So I grabbed this from what is it, Stack Overflow or Towards Data Science, and it says, when must you use LaTeX? So if you're in academia, particularly any STEM discipline or manuscripts or everything, it formats it perfectly for you every time. You work with a lot of bibliography, so LaTeX plus BibTeX. So BibTeX is the file I just produced from Mendeley. You get a lot of references, so there's papers with 40 to 60 references. You put all those in Mendeley, produce a bib file, and instead of having to manually format each one, it does it all for you. Or you use formulas. So actually the math formula editor in Word is based on LaTeX anyway, so you can cut out the middleman and write them directly in LaTeX. So that's what LaTeX is. Overleaf is an online collaborative writing publishing tool that uses LaTeX. It provides all the convenience of using LaTeX with a cloud-based system that's easy to use, it's online, it's collaborative. So again, I grabbed this from either Stack Overflow or Towards Data Science. I think it's Stack Overflow because there's a question. And it says, why would I use Overleaf? Number one, ease of use. Overleaf is a ready-made tool. So LaTeX, like Python and R, you need to download all the stuff. You need to have an IDE. Overleaf cuts all that out for you. All you need is an internet connection. It does all the work for you. It's mobile. It's on the internet, so you can work anywhere you want. You can collaborate with LaTeX, and you can organize your document organization template. So there's a bunch of templates from any journal has a LaTeX template that you can import into Overleaf and automatically produce what the journal is looking for. So the last thing I'm gonna do is show you how this works. So Overleaf. So here's an example I built for green building, but I'm gonna go ahead and show you some different examples. So this paper, contributions, I submitted this to the Transportation Part D, if I remember, Transportation Part D, Transport and Environment. And I typed all this up. So this is, it looks like code. So you have section, introduction, then you type what you have. Then notice you have cite here. This is half the power of it. It automatically cites things for you where you want them to cite pretty easily. Have different sections. So it looks like code, but the cool thing about Overleaf is if you can't read this or you don't want to learn the LaTeX code, you can. It has its own Word-like format that just looks like Word again. You can still use the code to cite different things. You can bold, italicize, you have bullets. So all the things you expect, well, maybe not all the things, but some of the things you expect from Word are also in here. I've gotten used to writing it this way, and I actually think it's more powerful, but it's gradually introduce you into how you write these. So this is overleaf. This is a paper I written, and the formatting, if I go all the way to the top, for the journal is, where is that? Dun, 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 dun. Let's see it somewhere. Oh, scroll higher. Ah, here it is. Document class, ELS, which stands for Elsevier, which is the journal that this is based off of. Article, TRD, Transportation Research Journal. So this is the template that Transportation Research uses. So if I look Elsevier, Transportation Research template, overleaf. Let's click here. That one. Oh, I don't want to survey. Sorry. Let's go back. Here you go. Gallery. So here's a gallery of templates for Elsevier. So there's a single column template. There's a Science Direct template. And if you click on this one. If I click on this and open it as a template, it takes half a second. This is the proper journal format for whatever journal this happens to be. Starting in 2 columns. And here's the code for it. So you don't have to do anything else. This is in Spanish, which is unfortunate for me, but it already comes in a template, and all you have to do is type what you want to add to it. And it has the templates for pretty much any major journal, IEEE, Informs, ISE, anywhere that you want to publish, ACS, etc. There's a template in LaTeX, and there's an easily click here button to put this in the overleaf, and you just have to start writing. Don't have to worry about the formatting. Don't have to worry about the citations. And that is the next step I'll show you. So that's my paper. You notice here's the main tech file. This is what I'm writing here. Here are all the images files, which you upload into this folder. If I go to the main tech file, there should be an outline somewhere. There it is. Results. I have figure reference, so you can reference the figure, so you don't have to worry about, did I do figure 1 right? Did I do figure 2 right? It does all that for you. But to insert a figure, again, it looks like code. So you begin figure here, I center it, include graphics, vehicle mix. And vehicle mix is a JPEG I have here. So it includes a JPEG, does excellent citation formatting for you. Center the figure again, end figure. And that, I can get to that point. Where's that point? And figure's right here. It has a caption, it has the JPEG that you outlined already. And you insert that exactly where you want to in the text, and it formats around it in the journal's format. A very powerful tool. So I'm going to go back to projects, lab example. So I created this using the SCS format. So this is Sustainable Cities and Societies format. It's the same document class because Elsevier is the journal editor or the journal collaborator or operator. You have a bunch of packages. You don't need to worry about those for right now. And so I have an abstract right here. I didn't really put anything. So green building is cool. Here is some words for abstracts. You add your keywords. So I have green building, decision analytics tutorial. You hit recompile, and all that new stuff should show up. There it is. Then you have your section. So it skips a page. So new page for your introduction. This is an example of why we're going to use overleaf for our example. So I already have the bib file in here from, I don't know where I got this from, so I'm going to delete this bib file. Delete. I'm going to take the bib file from here. So I'm going to look at, I'm going to grab everything. I'm going to take this. I highlighted all the things from our shared folder. So these are citations that everyone's added. I'm going to export this as a bib file. Called export 1 now. So I'm going to just change that, to be honest. Show in folder, delete that one. Rename export, makes it easier for me. I'm going to go back here. So I deleted the bib file, and down at the very bottom are references, just like in a regular paper. Whoops. That's of it. There you go. So you have your subsections, etc. References. And all you have to do here is slash bibliography, the name of the bib file, and the bibliography style, which also comes from the journal. So I deleted the bib file that I had here. So I'm going to upload the one I just made that came from a shared folder that I just downloaded. You all saw me do it. Export. And I'm going to scroll up here. I'll recompile that for 1 second. So this I already made. This it came from my shared team folder, so it's the same. But say I wanted to look at a new journal. /site, parentheses, and then all the references that are in that bib file should show up, but you probably need a little more. So start with S. All the S's showed up. So I'm gonna say this paper looks at X and Y. Then I have another paper, /site, looks at, like a D, no D's, E. Let's try F. No. Michael looks at W and Z. I hit recompile. And then there's my new paragraph. This looks at X and Y. Michael looks at Y and Z. But the best part about all that is that if you scroll down to the references somewhere, well, that's appendix. References there somewhere. Conclusions. I don't know. Oh, small problem. Let's see what happened. Scroll down to references. Section references.
Eric, I saw it. It was on the right. Just FYI.
Right.
I did see it.
Should be here somewhere. Huh.
Keep going down, I think.
So this is also some
there
of
it is. There it is. 21.
Ah, here they are.
Yeah.
It adds all the references that I cited. So the bibliography file is enormous. It has all the things I've added to it. But the actual bibliography that produces in the document is only the things I have cited in the work. So Michael, Nickton, the one I just so something, and it cites it in alphabetical order for you. Also, depending on your bibliography style, say if you use IEEE, it would use the number format. It does that automatically. It puts it in the correct format, and all you have to do is open the paper, add it to Mendeley, export the bib file. It's all here. And only the references that I've cited in the document show up in the references file. It's a huge time saver just on that aspect. And also the formatting is also extremely helpful once you get used to the coding style. But again, you can always just use rich text and work on it like Word. So that is, I think that's pretty much everything I want to cover. So it's overleaf demonstration. Oh, okay. So adding a bib file, you go to templates, search Elsevier for your whatever template you want to use. You open it as a template, you fill in some areas, you add the bib file to the folder, you type the bib file's name in the bibliography section, you compile the paper, and it all shows up. And yeah, that's my last slide. So hopefully that's helpful to whoever's here, and I can take questions. Yeah, stop sharing.
Thank you so much, Eric. I have so we got a couple of questions in the audience. The first question, one was a brief comment here. So let me just get to the comment here. It says, just superb presentation. I suggest you give the seminar at the college level. This is a college level, but it says question, and it says recommend you include patents. So I don't know how much you know about patents, but if you have some thoughts on that.
I don't know much about patents, not gonna lie. I can look into it. I'm sure there's a reproducible way for that as well. There's not, there should be, and that's could be a new area of direction.
Yeah. The next, there's several people are asking for two things that I've just kind of been tracking a little bit. One is, do you have a copy of the slide deck or the links that we can make available? If you've got the slide deck, I think we can go ahead and post. If you can just send that to Tanya, we can post that on the virtual brown bag. So if that's okay with you, we can put that when the video for this goes online, goes up on the webpage. We can turn around and put the deck with it if that's okay.
Oh yeah, this is meant to be shared, so I will send that and then get that in our proper channel.
Perfect. And then the next the next thing was that there was somebody also asked, it looks, I think Tanya already answered this one. Is the video being recorded? Yes, the video is going to be recorded. She responded to that in the chat, and it's posted on all the virtual brown bag seminars are posted at go.uta.edu/COE-VBB for virtual brown bag. It's posted in the chat as well. Oh, and so the one other person, we did have another question here. And that is, so what makes using Overleaf more useful than more common editor like Microsoft Word or Google Docs?
I think I kind of brushed over this little graph here, but I'm gonna show it again. So Overleaf, yeah, we can see it. Word is actually really helpful for a lot of things. Group projects, just writing notes in a meeting, agendas, etc. But as you increase your document's complexity and size, just formatting that for a journal takes forever. Just figuring out how the citation works, and you have to do it all manually, takes forever. So as your document increases in complexity and size, eventually it gets to a point where Word just becomes unwieldy, or you have to sacrifice the quality of your formatting to fit it all in Word. So dissertations are a bad fit for Word because they're hundreds of pages long, and it's just really hard to get all that going. So the effort and time it takes to do things as the document gets complex starts favoring LaTeX more and more. So for short documents, if you're working on a group project, Google Docs is A-okay. If you're trying to submit a paper, you can probably do it in Word, but once you learn LaTeX, it'll be much faster, especially in Overleaf and just with citations alone. So as effort and time goes up, as document complexity and size go up, the effort and time it takes to do it in Word increases dramatically, but it's a smooth increase for LaTeX. So that's the power of that. Also helps with the equations. It's much easier to write equations in it. It's much easier to center figures in the appropriate style, etc. But if you're only working on small documents, go ahead and use Word. Google Docs is fine. It's a great tool. But if you're submitting to journals, dissertations, etc., I can't recommend LaTeX enough.
I just, my own personal comment was always, if you've got more than 3 equations in your document, use LaTeX. And nearly all of my journal publications have more than 3 equations in them. If you can do 3 equations and they're relatively simple, but once you start getting into the complicated equations, that's when it's best just to switch to LaTeX. So I got another comment on patents, by the way. Just simply, please comment on the importance of patents. It is to ensure we don't miss the latest research industry, the latest industry research. So that's posted in the chat. Great comment. Absolutely, there is an important. Yes. Certainly, the patents are very important to know about what's the latest, particularly in industry research, because a lot of industry people don't necessarily go and present their work at various conferences and don't publish, but they do get patents, and patent going through that is there. Couple others, just great presentation, I'm not totally sure I follow this one comment that says not reflected in publications as they are. Oh, that's on the that's on the patents again. Yeah. So yes, very clear on the patents. Would be interesting to add a patents piece to this term. I think I have covered all the questions. I do want to say, do you ever find yourself, though, perhaps in some of this stuff being almost, for lack of a better term, overly organized, or if you are more like, I guess, whereas I totally agree with your Overleaf, your LaTeX versus Word doc. Do you have something similar for things like our studio and thoughts on when to use kind of when to use our studio, when to just bang something out in our studio or really write code for our studio.
So I will say, as a grad student, I was just banging out code. I'm just trying to get results, put them in papers, and send them off. I still use Overleaf as a grad student because it's just much easier to write in, and LaTeX and Mendeley and all that reference managers. But as I started maturing as a researcher and I wanted to look at old work, I wanted to use old code, I just couldn't read it. I couldn't produce the same graphs I produced. If I wanted to change something for reviewers, reviews take forever. So 6 months later, I was like, oh, let me just reproduce this graph. A package changed. I didn't know. I tweaked something to make it work just so I can have it working and print it out. But now I need to do it again. I couldn't do it. So that's where the reproducibility comes in. And it's not that hard if you have a plan of action. That's hopefully what I was hoping to provide. You just you put your documents here, you write some comments here, you have your notes, and you follow this format. And once you get used to that, it's just much easier to revisit your own work. So ignoring sharing it with other people so they can use it, just so you can use it 6 months down the line. And I would highly recommend it's practice makes perfect. It took me a while, but once I started doing it, it's second nature. And now I can look at code from 2 years ago, like, oh, I did this and this. I use this package for version 3.9. So it's probably been upgraded. So if I have an error, I know why. And I can reproduce what I've done myself. And this is a big problem in research in general, is that we are producing all this code, we're producing all these results. And if somebody comes even like 6 months down the line, is like, oh, I want to do what you did, it can't be done, and you can't even tell them how to do it. So there's an effort up front, I will agree with, but I think it's worth it.
Yeah, I just want one other thing too, in terms of some of this stuff, it does depend just from a coding perspective, and maybe you can comment on this too. From a coding perspective, if you're going to go in industry, and this isn't, I don't think you mentioned this, but so I'll mention it, is that when you go into industry, if you're going to just do code, they usually don't care too much if you're just going to do code to find some answer that they want to know these answers for this particular thing. No one cares too much about it. But if you're going to use code that's going to go in, like for a software developer or a software engineer, then you need it's a very high level of integrity and just a high level of a high coding standard. So I think in some sense, some of this what you've just described is almost more important if you're going to go into an industry position and where you're going to be developing code, particularly commercial code. Commercial code absolutely has to go through a lot of testing and high levels of standards. I just thought, do you have any comments or thoughts on that too?
I agree. I mean, definitely if you're a software engineer, computer science engineer, you're going to need to know how to do this. You're going to have to learn real fast. But it goes just beyond code too. So even as a regular engineer, you have to report what you do. If you run an experiment, you have to be able to write down what you did, your results, and then how someone else can do it in the future, especially if you change jobs or you have to train someone later down the line. So reproducibility in general is important, but in code, it's kind of overlooked because, hey, I produced my graph, I shoved it in my paper, I'm done. But I would say no, you have to make sure that you can do it again, and so can someone else.
Okay, we did get another. This is. I mean, so I honestly, I don't think I've seen so many interesting comments on these before. So let me go ahead and read this one. This one's great. It says, back in the days, I wrote a 22,000. Am I reading? I might be having the zeros wrong here. Is it 22,000 line Fortran code with hardly any comment? Wish I had your presentation. So, yeah, I've written my share of spaghetti code too, but I did one summer with a software engineer and I have never written a piece of spaghetti code since then. So, yeah. Well, are there any more comments, questions in the from the audience? Because we are getting about that time. Okay, I don't see it. Nothing's popping up in the Q&A. So I'd like to just once again thank Dr. Jones. Great talk. I really think it's informative. In fact, as far as I'm concerned, I'm glad that this is going up on the Virtual Brown Bag website. I hope they keep it up forever, so that way my PhDs have all seen this presentation before, but the next PhDs who come into me, I'm just going to hand them a link and say, hey, go watch this and go do this. Go watch this and check out the slides so you can understand, because this is the type of thing that I want you to be able to do. It saves me all the time of having to train them. It saves you and everybody else all the time of just having this out there. So very excellent resource. Once again, the webpage for that this is being posted on, and which will also include the slides, is go.uta.edu/COE-VBB. Again, thank you very much. As always, we generally the Virtual Brown Bag is be on the lookout for the next series. Unfortunately, I don't have them staring at me in the face yet, but they're generally on Wednesdays at noon and Fridays at noon. So these are great. These are great to learn about various things for just students to train with and so forth. And thank you very much.
Thank you.